Hello everyone. Previously we had discussed on the Morris traversal algorithm, right? So today we'll be going with the diameter of the tree algorithm. So this is one of the important algorithms as well, right? Usually we solve this using the this one 2BFS or the 2DFS, right? So usually we do it, or else you can just go with the recursion as well. So I'll just go with the 2BFS or the DFS. Let's see first what we are gonna do. Let's get into the definition part first. Let's discuss the explanation part as well. Then we have to implement that one in the form of code or this one, right? So let's see first what the definition part say here, right? So let's get into the definition part. So what does the definition part say here? The diameter of a tree is the longest path between the two nodes. It is just the longest, right? Longest path basically between the two nodes in the tree. It can be found using BFS or the DFS traversal. See here, it can be found using the BFS or the DFS travels or using the recursive DFS again, right? So we have already solved many problems basically, right? Many problems in the trees. So also if you would have observed, we solved something named diameter of a tree. This one, the problem to find the diameter of the tree was there actually in the LeetCode, right? If you remember, the same thing. So here we will be this one going with the same algorithm. So we'll be implementing the same. I think I'll not get that chance to do for the YouTube because I have already solved the this one problems on the trees. Basically we are left with only 3 things basically. So we have finished solving the problems on intervals as well today. So we are left with bit manipulation, dynamic programming, as well as the graph in the LeetCode, right? So and again in the CP we are almost done with the dynamic programming. 49 problems we have solved using this one dynamic programming. So I said you earlier that we'll be solving 50 problems on the dynamic programming and 50 problems on the graph basically, right? So we have completed 50 problems. We will be completing tomorrow basically. So we'll be completing dynamic programming problems basically 50 problems by tomorrow. So the last 5 problems we are solving basically very easy or easy based problems. Usually this one, what do we call the problems that are rated above 800 and below 1500 we are solving just now, right? So this one, what do we call dynamic programming problems, the last 5 problems I'm speaking of. Usually we solve very complex one or the this one hard or the very hard problems basically till now. Now we are solving this one very easy or easy, the last 5 problems. This is fine. Now next from Wednesday usually we'll be starting with the graph basically, right? So and from tomorrow the LeetCode problems will be starting with the bit manipulation, and this one we have already solved the diameter of the tree, this one base problems in LeetCode, right? So we are having the idea, so we solved that one using the recursion, right? So recursive DFS. For this one, let's make use of the 2BFS. Let's see what we can do, how we can basically write the algorithm further, right? So after discussing the explanation part. So this one again, let me tell you or let me read this one out loud. Just listen to this carefully. The diameter of a tree is the longest path, right, between two nodes in the tree. It can be found using the BFS or the DFS traversals or using a recursive DFS approach, right? So this is fine. Now let's get into the definition, this one explanation part. The first part here would be we have to choose any node as the starting point and perform DFS or the BFS to find the farthest node from it, right? So we have to choose any node as the starting point and perform BFS or the DFS to find the farthest node from it, right? So this is fine. Again, all we have to do is we have to choose any node as the starting point and perform BFS or the DFS to find the farthest node from it. Just remember this one. Again, the second point would be we have to perform DFS or the BFS, depth first search or the breadth first search. Again, from this farthest node just to find the maximum distance to any other node. So we can find the maximum distance from this one to any other node as well, right? So in that case we have to update this one maximum distance at that point, right? So this maximum distance is the diameter of the tree, the maximum that we get, right? So among all the things that we had computed, the maximum that we get, that we will return as the this one diameter of the tree basically. This maximum distance is the diameter of the tree, right? So this works because the diameter must start and end at the leaf node. It has to start and end at the leaf node, and the 2-pass traversal ensures we cover the farthest endpoints. So we will be going with the 2-pass traversal, meaning we'll be making use of the 2BFS or 2DFS here, right? So the 2-pass traversal ensure we cover the farthest endpoints, right? So as I've said, we'll not be making use of the recursive DFS, we'll be going with the 2BFS, as I've said, right? So let's do one thing. For this point, now I'll not be making use of the recursive DFS or the DFS. So let's do one thing, let's make use of the BFS, right? So we will be making use of this one DFS or the recursive DFS quite often, right? So I have made use of mostly the recursive DFS to solve the particular problems, to solve most of the problems in this one tree, right? So even in the graph also, usually we go with the DFS, except there are some problems that has to be solved by BFS itself, then we go with the BFS, right? So for this one I want to make use of the BFS, so I'll be going with the BFS instead of the recursive DFS or the DFS, right? So first let's do one thing, let's import the DQ for BFS. So I'll just go with so this is not showing anything, so let me type human from collections. So now this was showing, this is fine. Import, so what we have to import, let me import DQ, right? So this is fine. The next step would be, let's write the function to perform the this one BFS, breadth first search, and return the farthest node and its distance. So I'll just go with that. So this one will be BFS, or let me go with normal BFS. So this is fine. Start and this one, start and adjacent, this one will be the basically parameters, right? So this is fine. Let's create the queue for the BFS man first. Let's think about other things later. So this is fine. Next part would be queue dot append. So this one will be start, so this is also fine, and let me assign this one distance equals start, so this one will be 0. This is fine. So we are just storing the distances from the start node. Now let's do one thing, let's go with the farthest node here. Where is farthest node? We haven't went with the farthest node, right? So just give me a second here. Yeah, let me do one thing, I'll just go with the farthest underscore node here. This one, let me assign this one to the start. So I get confused because usually we mention the data types, right? So this one in the Java, most of the times I feel like mentioning this one data types. Java screams basically when you don't give the data types. So here this Python is it's usually writing the code in English basically, right? So I get confused sometimes. So this is fine. Let's move on with the further things. So we are just tracking to track the farthest node, we are making use of the farthest node, this one variable name. This is fine. So I'll just go with while of q. So we are going with the BFS, right? Obviously we'll be going with the q basically. So let me assign the q, this one u to q dot pop left. So where is pop left? Pop left. This is fine. Next thing would be, let me make use of the for loop for v and adjacency of this one u. This is fine. So we are just traversing all the neighbors of node u here, the line number 26. Don't get confused here. In the line number 27, if it is not visited, suppose if we not distance, this is fine. Then what we have to do, then we have to update the distance, add to the queue, and update the farthest node that is found, right? So for updating the distance, I'll just go with the distance of v. This one equals distance of u. This is fine, plus 1 plus 1. Then we have to add to the queue, meaning, so I'll just go with q dot append here of v. This is also fine. Next let's go with the if condition. If distance of v, this is fine, if it is greater than distance of this one farthest node. So this one will be farthest underscore node. This is also fine. Farthest node, So this is also fine. Let me assign this one to the v. So we are just updating the farthest node that is found, right? So this one we have already discussed this one in the approach. The same thing, exact thing we have implemented in the form of this one code or the algo, right? By making use of a Python programming language. This is fine. Now let's do one thing. We have to return the farthest node and the distance both, right? So I'll just go with a return for the farthest node. We have considered farthest node itself, right? So for the distance we have to go with, we have considered not the dict, actually we have considered distman. Yep, distance of farthest node. So this is fine. So we are done with this part, man. Now let's do one thing. So let's write the main function, nothing but function to calculate the diameter of the tree. So I'll just go with def here, tree diameter. This is fine. We need parameters, one is n and another one is edges. So I should have written e. This is fine. Let's write full so that we understand clearly, right? So usually by computing on this one Codeforces and what do we call CodeChef, as well as the Edcoder and this one what do we call LeetCode, I usually go with a single character variable naming, usually most of the times, 90% of the times. So I feel like giving the single character most of the times. This is fine. Except the main function, I usually go with the this one single character variable naming. So let's do one thing. Now let's move on with the further things. Let's create the adjacency list here. So I'll just go with adj. So this is let me go with empty this one array for I in range. So this one will be 1 comma n plus 1. Let me come out of this one entirely for u comma v edges. So we have went with a for loop, right? So this one will be easy, adjacency of u. So we have to append v here, and same goes with vice versa we have to do, right? So we'll just go with here u and this one v. So this is fine, man. We are doing this one at the right time basically, because the next basically from day after tomorrow we'll be starting with the graph. We'll be solving the graph problems, right? So basically tree and graph will be going with the DFS, BFS along with certain algorithms. So those algorithms are similar, sort of similar, not entirely, but some of the problems, some of the algorithms that will be implementing both on this one, trees and the graphs basically, right, including the DFS, BFS, right? So we are doing this one at the right time, no worries. So this is fine. Now let's do one thing. First step, let's go with the BFS from any node, say 1 to find the farthest node, meaning here I'll just go with far underscore node comma. So this one underscore equals, let me go with BFS of 1 comma AD. This is also fine. I have given ADJ, right? Sorry, this is fine. And also we have to go with the BFS from the farthest node to the to find the maximum distance as well. That also we have to do. So this is nothing but the step 2. So line number 43, what we are doing, we are going with the step 1, nothing but BFS from any node. Suppose if we consider 1 to the farthest node, right? So step 2, now what I'll be doing, so we have to go with the BFS from the farthest node to find the maximum distance. So this one will be far node. I'll just give 2 as I've considered for node already. So this one, let me go with diameter. So I've considered so let me go with the diameter. So this is fine. So this one will be BFS of far node comma. So this is fine, man. So now let's do one thing. Finally let's return the diameter, man. So I'll just go with return diameter. So this is fine. Yep. This one I haven't given comma here. I missed the comma here, I will. This is fine. Now this has to work correctly. Yep. We have just returned that diameter, right? So this is fine. Now we are done with the algo. This is it. We are just calculating the tree diameter here. For that one we have made use of the helper method BFS basically. So to perform the BFS we have made use of BFS helper method, right? So this is fine. Yep. Let's do one thing now. Let's move on with the example usage. So first let me consider n number of nodes or the edges. So let's go with 5, 6, 7, 6. Yep, this is fine. Let me go with the edges here within the array. So first edge I'll just go with a 1 comma 2, then 2 comma 3, this is also fine, and then let's go with 2 comma 4, this is also fine. Then let's go with this one 2 comma 3, 2 comma 4 we haven't with, right? 4 comma 5 and 5 comma 6. So this one 4 comma 5 and 5 comma 6, right? So this is fine, 4 comma 5 and 5 comma 6. So now let's do one thing. So let's find the diameter. We have to find the diameter, so I'll just give result here equivalent to, let's call the tree diameter function where we are calculating the diameter. So let me pass n and edges. So this is fine. Now let's print something for the interactive purpose. So I'll just give print here. So I'll just give here diameter of the tree is, so here is, so let me call the result here. We are storing that one, the result itself, right? Output. So this is fine. Let me do one thing. Let me format the code once. So this is fine. So this one far not to have not. Just 1 second, man. Just give me a second here. Far not. Yep. This is fine, man. Yep. Let me do one thing. Let me copy this one. Also, let me do one thing. Let me give Control J here. Python followed by this one, file name .py. So let me, we are getting the output diameter of the tree equals 1, right? So basically we are getting the wrong output, man. So the longest path, so we have considered n equals 6, right? Just give me a second here. See here, accordingly with the this one example we have considered, see 1, so 1 to 2 we are going, so this is fine, right? So again 2 to 3 we are going, and 2 to 4 we are going, right? So this one will be 2 to 3 and 2 to 4 basically, then 4 to 5 and 5 to 6 here, 4 to 5 and 5 to 6 here, right? So this one diameter that we need to get here is basically this one 4, right? Accordingly with what we have considered edges 1 to 2, 2 to 3, 2 to 4, 4 to 5 and 4 to 6, right? 5 to 6, sorry. So this one we have to get 4 basically. See, the longest path is from this one, what do we call, 3 to 2, 2 to 4, 3 to 2, 2 to 4, this one 4 to 5 and finally this one 5 to 6. So this is the longest path basically, right? So this one 3 to we are considering this part basically, right? So it starts with the leaf and ends at the leaf, as I have said. So this path we have 4. This is nothing but this path length has 4 edges, right? So this 1, 2, 3 and 4, this path length has 4 edges basically, right? So the output that we need to get here is 4, but we are getting the output 1, which is absolutely wrong, right? So somewhere we have done wrong thing, right? So diameter of the tree is basically for this one is 4 basically, right? So we are getting 1, which is wrong. Let's check what we have done wrong. So let me delete this one. So yeah, what mistake I have done here is, see, I have given far node and far node to this one, this line basically, along with the within the for loop basically. We have to move this one outside the for loop, right? So this one again, many times I go with this one, wrong indentation. So I'll just move these 3 things outside the for loop, right? So let me format the document once. Let me give clear screen here. Let me run this one again. So now we are getting the diameter of the tree is 4. Yeah, this was the main problem basically, right? So everything was fine. So this one I had given within the for loop basically, which is wrong actually, right? So we have to give this one outside the for loop, including the return statement, right? So this one basically, now we are getting the output, which is absolutely correct. So I have already shown you why we have to get the output 4, right? right? So I have shown you by building the tree and showing the diameter, right? So I hope this part is completely clear, man. Let me explain this one once again so that we don't forget, right? So this one from collections import DQ. So this one we are just importing the DQ for efficient BFS queue, right? So we are making use of the BFS and BFS along with the queue. So we are importing the DQ for the efficient BFS queue here, right? So this is fine, I believe. Next, we have went with a BFS function here. Basically this is the BFS function just to find the farthest node and its distance. So this is the helper function, right? So to find the farthest node and its distance, so dist equals start this one 0. So we are going with the distance of start node, which is 0, right? So next we have made use of the for loop here, this one, the line number 27. So this one we are just looping through the neighbors of u, and if v not in dist, I have give here this one line number 28. So if the neighbor is not visited, then we have to update the distance, right? So if distance of v, this one line number 31, whatever I have written, so this tracks the farthest node dynamically. We know this one, right? Finally, tree diameter we are going with this one, main function. We can call this one as main function, right? So this builds the adjacency list and calls the BFS twice. So we are calling the BFS twice here. See here, once, twice. We are calling the BFS twice. Previously I had said that we'll be making use of the BFS this one twice, so which is equivalent to this one itself. We will be meaning, so we are calling or we are making use of the BFS twice. So only one BFS function we have written, basically, which finds the farthest node and its distance. Now we are making use of it twice here, right? So this is fine. Now tree diameter function, what it does, it builds the adjacency list and calls the BFS twice. So the first BFS, this one, the line number 45, the first BFS, it finds one endpoint of the diameter, and the second BFS, it finds the longest distance from that particular point, right? So the longest distance that is found, that's found because of the return diameter that we have given here. Finally, we have this one, what do we call, we have defined the edges. This represents the tree structure. Basically I have shown you the build, this one, the tree build, and how we got the output 4, how we got the diameter of the tree 4, right? That one I have already shown you. And finally we are making use of the print statement here just for the interactive purpose, meaning we are printing the diameter result here, right? So this is fine, I believe, right? So this is it for the diameter of the tree calculation algorithm, right? So this is it for the diameter of the tree calculation algorithm, right? So I hope this part is clear, man. Let's do one thing now. Let's go with the this one, what do we call, so this one, let's move on with the summary part. This is fine, right? Summary in the sense, we'll be going with the basically we are done with the diameter of the tree algorithm, so we'll be going with the our let me summarize whatever we have learned so far. Just try to remember these 3 or 4 points, man. This is very important. We have already discussed this one. I'm just summarizing this one, so this is very important basically, right, along with the algorithm. So diameter is nothing but the longest path between 2 nodes in the tree. So this one we had discussed on the this one definition part, right? So diameter is the longest path between 2 nodes in a tree. So this is found using 2 BFS or the DFS traversals. This is found using 2 BFS or the DFS traversals. So what will be the time complexity? The time complexity would lead to big O of n here, right? So why it is big O of n? Since BFS or the DFS visits each node exactly once, the time complexity would lead to big O of n. So what would be the space complexity? Space complexity would be big O of n as well, because we'll be making we have made use of the adjacency list and the BFS queue, right? So try to remember these 3 or 4 points. This is very important, right? So we are done with the diameter of the tree algorithm, right? Next, what we'll be doing, basically we will be discussing on the LCA, lowest common ancestor, right? So basically this will be for the this is for the binary lifting or the range minimum queries, right? So we'll be discussing on the LCA algorithm next. For now, this is it. Thanks for watching, guys.